It is the margin material. Whether it is GFRP or steel stirrups, if you choose the appropriate, no, a very no, a very good spacing, design is very good, you won't get any shear. No, shear failure, no diagonal. So I think that is a main straight bar, and you want to have the spacing so that if the glass fiber, if the spacing is good, then we don't bring in any steel at all as stirrups. Glass fiber at the bottom, and then steel stirrup. But look at the spacing. The spacing is 300 centimeters. And you see it is filling, it has filled diagonal here. At fill your rest. And then this one, steel at the bottom, steel and so on. This one, okay, this one is also interesting. This is beam. The beam has steel main bars, and then the glass fiber has stirrups. So the failure is quite normal, no shear and so on. So glass fiber stirrups are effective. This one is steel, but because I think the previous one, the spacing is 165, so it's good. Yeah, but here 300, so still getting the diagonal here. Okay, here we have the low deflection curves, and they are all similar, irrespective of the type. I think there's not much time. I don't know what I've gone to. However, can I go on? Introduce the two-way, 5 minutes. The last one is a two-way slab. Two-way slab. When you are in designing those in concrete and structures, so we say two-way. We have one-way slab, we have two-way slab. If you say two-way slab or panel, it means the ratio between the length and the breadth, or the width, is it the breadth and the depth? Right. Is not greater than 2. It's at most 2. That is the two-way slab. So, no, we're also concentrating on slab because the major application of glass fiber is in bridges, especially in the cold countries. About concern with the de-icing salt and so on to melt snow. So that is one major reason glass fiber has come to be used. I think it was mentioned bridges, tunnels, and so on. Those structures exposed to chemicals and salts because of corrosion. 1970, to be used as reinforcement. It first started being used in the aerospace after the World War, but after they see that it was very durable material. So the 70s, and as I said, Canada started the first application was 2005 or so. The US, all recent, Europe, same, Japan. So they are, this, and as I said, the major reason is in particular in the bridge decks at USC, Civil Engineering Department. And here, everything is glass fiber, so both directions. So the tested, right, and low deflection curves were plotted. This was both on the monotonic, so this one is cyclic loading. So when I say cyclic, you see it's all in one direction, tension, right? Came to 0 and then increase again, not tension and compression. Because you go to compression, you'll be in trouble. So tension and compression, only tension. So cyclic loading. I think the first one was monotonic loading. Okay, no. Okay, this is monotonic to feel you are right. So very significant, loads carrying capacity. But one thing that has been found is about its resistance to punching. So if you look at the loading is a punch load in the middle. Low point load in the middle. So maybe in the real application, we will have a flat slab. So have a column in the middle, no beam. Right. No beam. So the findings from this research, can be applied when we are dealing with flat slab. Because the major finding is that the problem is with punching shear. Punching shear, you see, and around the point of application with load, which is like a flat slab is there. So our next series of investigations is to find ways to arrest, ways to improve on the pointing share. I know Viva is proposing that the hard rate maybe bring in, find a way to either bring in steel and so on. We are using, let's say, steel fibers to improve on the tensile strength of the concrete in that vicinity. If it is flat slab, what we can do, we can have other broadhead, right? We can broadhead, increase this thing. But if it's a load like we are doing, we can't even to push with enlarging the base, it will not work much. So either we bring in steel in that way, assuming it's a pond load, heavy machinery load at the center of this thing, and we have that. We want to prevent punching. We can maybe introduce steel, a grade of steel in the middle or where the pond load is. Or we will also test using glass fiber to see. So we have the glass fiber at the top there and then also at the bottom. So also going to be a combination of this. And so that is the end of the presentation. Thank you.
All right, thank you so much. We want to take one or two questions, and then we take the next presentation. So I'll give the opportunity for some questions, and then we take the next presentation quickly. So I see hands. Let's take one here, and then do one at the back quickly. Quickly, we just have some few minutes. Can we get extra microphones? Okay, this one is working.
Prof, thank you. My concern has to do with what was your observation when you were bending the FRP to be used for the stirrups, and because of the accurate issue, whether that was you found some cracks is not good enough, or I want to have your comment on it. Thank you.
Yeah, Prof, should we take all the questions and then we? Okay.
Yeah, okay. Thank you very much. This is an important question. As I mentioned, that for example, at the end of the bar, you can't bend into, let's say, hooks and so on. I mean, at the site, but it can easily be done in a factory if the manufacturers want to do that. So the stirrups, the same way, the stirrups cannot be bent into shape. So the stirrups were, so this is steel, right? When you are using the hybrid, then this is steel. It's in the presentations, so GFRP, right? Right. So the GFRP, the stirrups were cut into, let's say, 4 parts. 1, 2, they were pieces and tied together. So grooves were made at certain point and then tied with the binding wire. Yeah. So perhaps that is why if you don't get the proper spacing, you don't get it. The tying is also very important. You don't tie it well to make it rigid, it will become useless. So still, this one once you bend, it's rigid. But the glass fiber, at least in the lab, so if I don't have the machinery to bend, but better know, from looking around that some manufacturers produce stirrups, ready-made stirrups. But that one means that they were made to what? Other specifications.